Hi friends, good morning. My name is Achyut and I'm from Vizag. So today in this class we will solve another Java problem, right? So let's not waste the time. Let's get into the class. So this is my HackerRank, right? You can see, right? This is my HackerRank problem. So you can see my graph, right? The problem graph, right? So now I'll just read the problem statement, right? So the problem statement is given n non-negative integers representing an elevation map where the width of each bar is 1, right? Each bar is 1. Compute how much maximum water it can trap after raining, right? For example, consider this graph, right? And we are having certain heights. We are having 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, and 1. So these are the heights. For example, if you don't see anything, it is 0. And if you see any black spots here, then it is 1, right? And inside it, you cannot see anything, right? You will be having blue color, right? So which means it is a water. It is a water, but it has nothing. So that's why we are having 0. And we are having two blocks, right? And we are having 1 block, and we are having 0 block, and 1 block, 3 block, 2 block, 1 block, 2 block, and 1 block. The problem is you need to find how many units of water that you can fill inside this blocks, right? For example, we are having 1 unit, and here we are having 4 units. See here, this is 1 unit, this is 1 unit, and this is 1 unit, and this is 1 unit. This one, it is 4, 1 plus 4 is 5, and the final one is 6, right? By combining all these things, like all the units of water, you'll be having 6 units. You'll be having 6 units. So the problem is you need to find how much units of water that can be stored inside these blocks, right? So I hope you understand the problem statement. So the real problem is how can you calculate it? The real problem is how can you calculate this? So first you have to find the left maximums. First you have to find the left maximums and the right maximums. For example, we are having left maximum is 1 and right maximum is 2. And if you find difference between two maximum, left maximum and right maximum, so 2 minus 1, you'll be having 1, right? So in this way, we can find the units. We can find the units, right? So I hope you understand. So first you have to find the left maximums and the right maximums in that array, right? We are having some array, right? We need to find it and we need to subtract it. We need to subtract it from the current index. We need to find the left maximums. Like you need to find the all the left maximums in the array, and you need to find the all the right maximums from the array, right? Then you have to subtract. it. Then you'll get the lowest building. So based upon the lowest building only the water will be stored, right? For example, we are having 1. So based upon this building only the water is storing, right? The first thing is you have to find the left maximums in the array and the right maximums in the array, and you need to find the difference between the left maximum and the right maximum. So whichever has the lowest, right? Whichever has the lowest, that percentage of units will be, that units of water will be stored, right? I hope you understand the question. So let's write the code. Just go into the code. So don't worry, this is a dry run. So after writing the code, I will just explain it to you. I'll just explain to you. So let me adjust this thing. Yeah, I hope you can see the whole Visual Studio now, right? So first of all, you have to create the file. Just store maximum dot java, right? We have written the class. So first of all, you have to return the import java dot util dot star, right? So after that, you have to write public static void main string args, right? After that, you have to write scanner sc is equal to new scanner system.in, right? So after that, you have to write int n is equal to sc.next int, right? After that, you have to take an array is equal to new int of size n, right? Right? So you have to read the values in the array. You need to read the values in the array, right? You need to find the, you need to read the values in the array by using AR of I is equal to sc dot next int. So we are having the, we are having the n value and we are having the error value, we had read the values in the array. So now I will write the function called store maximum, and I will pass n value and the array values, right? So now I will write the function here, right, which is public static void store maximum, and I will write int n, first one, and int arr, right? So I hope you understand till now the code. So I just write the n value and I have declared the array and I have read the values in the array, right? So I have created the store maximum function, and I have passed the n value and the arr value. So I'm calling, I'm writing this function here, right? Right? The first thing you have to do is you have to create the array. So L maximum int L maximum is equal to new int of size n, right? So what I have created? I have created the integer type an array, right? So what you have to do, first of all, you have to find the left maximums, right? First of all, you have to write the, you have to find the left maximums. So I'll write the comment here. To find the left maximums, I have created the Lmax array, right? So likewise, you have to create the another thing, which is right maximum, right? New int of size n. I will just copy this comment here and I will just paste it here, right? So till now you have no doubts, I think, right? So I have just created an array, an empty array for the L maximum and the R maximums. To find the maximum elements in the array from the left and from the right. Right? So I will write right here and I'll write R here. So R maximum. Right? The first thing you have to find the you have to find the left maximum. Left maximum. Right? So first of all, I will write L maximum of 0th element is equal to AR of 0. Right? So after that, see here, what I am written is, first of all, I am taking, so in this array, I am taking the first element as AR of 0. AR of 0, which means whatever the element which I give, whatever the elements which I give, for example, we are having this values, right? We are having these or we can go to the here. We can go to here and we can take these values, right? And here I will just comment this values. I'll just paste it and I will just comment it here. So we have taken this array, right? We have taken this array. So I am telling, so in Lmax of 0, here I'm telling Lmax of 0, you have to put AR of 0, which means the 0th value. So what is the AR of 0? Which is, it is the 0. AR of 0 is 0. So I am putting this 0 value in this Lmax of 0 first. So I am choosing the first value as the maximum value, left maximum value as the maximum value, that current index value as the maximum value, right? So then after that, I have to traverse from I is equal to 1 to I less than n. So why I am starting I is equal to 1? Because I have initialized the 0th element, right? In the L maximum of 0, I have initialized the AR of 0, right? This is the AR of 0. So there is no need to start from 0, right? There is no need to start from 0. So that's why we need to start from 1. So it is index 0 and it is index 1. So that's why I'm starting from I is equal to 1 to I less than n. Right? I hope you understand. And I'm putting the first element as 0. Right? So then I am telling in the L maximum array, in the L maximum current index, you have to put the maximum element. So for the maximum element, you have to use math.max. So what I'm writing, I will take the current index. So this is the current index, right? This is the current index, AR of I, and Lmax of I minus 1. So I minus 1 is 1 minus 1, it is 0. So Lmax of 0 is AR of 0. What is AR of 0? It is 0. Right? So here you'll be getting 0 here. You'll be getting 0 here and you'll be getting 1 here. Right? Right? For example, in the Lmax array, first you will be having 0, right? So after that you are comparing this Lmax I minus 1 comma AR of I, right? You will find in the array and in the Lmax which is the greater, which is the maximum element, right? Which is the maximum element. So here you can find the maximum element is 1, right? So AR of I is 1, right? AR of 1 is 1, right? Lmax of I minus 1 which means 1 minus 1, you'll get 0. So Lmax of 0 is 0. So by comparing 0 and 1, what is the maximum value? 1. Right? So in the Lmax, here you'll write 1 here. Right? Right? I hope you understand. So why you are writing Lmax I minus 1 here? Right? Why you are comparing with AR of I? Because you have to compare to the left side of the array, right? So for the first time, what value you are having? You are having 0, right? So that's why you need to compare from the left side. You need to compare from the left side. So if that left side element is smaller, then the current index only the maximum value, right? And if the left side value is greater than the current index value, then the left side value is the maximum. So based upon that, you have to fill this array, Lmaximum array, right? With the current index in the array and the previous element in the Lmaximum array, right? I hope you understand. So like that, you have to find the maximum element, right? I hope you understand. Just I will remove this. So we got the maximum array, right? So in this way we can get the maximum array. So likewise, you have to find the right maximum, right? Right maximum. So for this, you have to write R max of n minus 1 is equal to ARR of n minus 1, right? So from the right onwards, you have to come now, right? From the right onwards, you have to come now. So I hope you understand this for loop, right? So we have find the left maxims, all the left maxims, and we have initialized those values in this Lmaxim. So in the same way, we have to find the right maxims. So first of all, you have to write the R max. So same thing. So from the left maximum, you have initialized the AR of 0, right? From the right maximum, you have to initialize the last element, which is AR of n minus 1. So n minus 1 will be the last value. See here, this is the last value, right? So for that, you have to start int j is equal to where you have to start? You have to start from n minus 2. Why? Because you have the last element as the value in the R maximum, right? So which is the n minus 1. So you will be having the last element as the n minus 1, right? You have already like initialized the values in the last element in the R maximum of n minus 1. I hope you understand. So the last element considered as the n minus 1, right? So we have initialized it. So the rest of the elements you have to initialize, which is j is equal to n minus 2, j greater than or equal to 0, and j minus, right? So here you have to write R maximum of j is equal to math.max R maximum of j plus 1 comma j, right? So here we have written I minus 1, here we have written j plus 1. Why? Because we have to compare from the right from, like we have to compare from the right onwards, right? So that's why we have to go to the next element. Right? So that's why we are writing j plus 1. For the left element, you have to write I minus 1. From the right element, you have to write the j plus 1. Right? So now we got the L maximum and the R maximum. Right? So till now, I hope you have no doubts, right? Simple. We have created some two arrays, R maximum and L maximum, and we have find the maximum from the left side, and we have find the maximum from the right side, right? I hope you understand. So now you have to find the units of water. Find the find the units of the water, right? So for this, you have to write int water is equal to 0, or you can write units of water, right? First I am initializing units of water is 0, and I will write the I will traverse on the array, right? See here. So what I'm doing is so instead of this, I will write int minimum building. First you have to find the minimum building, right? First you have to find the which building is smaller, which building is smaller. See here. So first you have to find the minimum building. See here, this is the minimum building or this is our minimum building. You have to find it, right? So first you have to, how can you find it? By subtracting the left maximum minus right maximum. And that I will write int minimum building is equal to math dot min, which is left maximum of k, comma right maximum of k, right? So then in this way you will get the minimum building, right? In this way you will get the minimum building. So then you have to write units of water plus or minus equal to minimum building minus air of k, right? So you got the minimum building. You got the minimum building. So you have subtracted from this building. You have subtracted from this left building to the right building. Then you will get the overall the small building, right? So after getting the small building, so if you want to find the how many units of water which is present beside the small building, then you have to write this formula, which is units of water plus or equal to minimum building minus air of k. Like you have to subtract the current index value to the minimum building. Then you will find the minimum water, right? So we have written the units of water plus or minus equal to minimum building minus air of k. So this statement is used to get the how many units of water which is present in the current index value, right? I hope you understand. So after that, I will just print the system.out. I'll just print the units of water, right? So finally, we have to print the how many units of water which are present inside this blocks, right? So that's why I have printing this units of water, right? So I hope you understand, right? So what we have done, so first we have given n value and array, right? So we have given the n value and the array, and we have created two new arrays, which is L maximum and the R maximum, right? So after that, I have given L maximum to the air of 0, the current index, the first index value to the air of 0. So then in the L maximum array, you will find the first element is 0, which is air of 0, right? Then you need to find the maximum from the left to right. So for that, you are looping the value from I is equal to 0 to I less than n, right? Then you will get the L maximum of I is equal to math.max L max of I minus 1 comma air of I. Like you are comparing with this 0 and the current value. Then you will get the maximums. So like this, you will get the maximums. Like that, you will get the maximum to the whole array. Right? I hope you understand. So I minus means the previous element. Right? So why you are comparing with the previous element? Because this is the maximum element, the first maximum element from the left. So you have to compare with this element. Right? If you find this element is bigger, then that value will be here. This value will be here. Right? If it is small than this value, then the current index value will be the maximum value. So like that, you have to compare whole array. So like that only right maximums. Right maximum, because the right maximum will start from n minus 1, right? N minus 1. So I'm initializing r maximum n minus 1 is equal to AR of n minus 1, right? So after that, I will loop this array from the ending, right? It will start from here to here, right? And I will find the right maximums. The same method will be followed here also, right? We find the left maximum and the right maximum. So after that, we have to find the units of water. How many units of water are there or not? So for that, you have to find the minimum building. So wherever you find the minimum building, so that amounts of units of water will be there, right? For that, we have to find math.min L max of k comma R max of k, right? Which means you will be having the updated array, right? L max array and the R max array. So you will compare that updated arrays and you'll get the minimum buildings. So after getting the minimum buildings, then you have to find the units of water. How can you find it? Units of water, like I have curated a variable which is equal to 0, and after that I will give units of water plus or minus, because I have to add each time, right? For each index I have to add the units, right? If you find any units, then I have to add it. So how can you add it? By subtracting minimum building minus the AR of k, which is the present index, with the present index. Then you will get the units of water. So after getting the units of water, then I will print that units of water, right? I hope you understand, right? So let's run this program. Click on F5, right? There is no errors. Let's give these values. So how many values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we are having n values 12, and we have to give 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, and 1, right? We have given the array. So after that, you'll get the output. You have to get the output 6, like the output should be 6. See, we got 6 here. We got 6 here, right? I hope you understand. I hope you understand, right? For example, we are having the debugging, like we have debugged the code. For example, we are having step 1, initialize the LMAX array, right? Left maximum heights, right? We have to get the left maximum heights, right? See here, we are having the array first. We are having all zeros in the array. All we are having zeros, right? So after that, I have to initialize the AR of 0 is equal to 0, like LMAX of 0 is equal to AR of 0, which is 0, right? First I have to give the value. This value I'm giving, right? See here, after giving the math.max AR of 1 comma LMAX of 0, then I will get 1 here, right? So like that, you will get the LMAX array here after updating, right? After updating, you will get the LMAX array, right? I hope you understand. So we are having LMAX of 0 is equal to AR of 0 first, and after that we will find the math.max. by iterating, right? See here. After iterating, we have to find it, right? See, we have to traverse from 1 to n, right? 1 to n, and you have to compare L max of I minus 1 comma to AR of I. AR of I. So that is what happening here. That is what happening. So when index 1, you will get 1. When index 2 will get 1. So like that, the array got updated here like this. The final array is updated like this, right? By comparing the current element and the previous element. So like that only the write max also. From right onwards, it will be updated. Then you will get the write max array, right? So finally, you have to calculate the units of water, right? For this, first you have to get the minimum value from the L max and the write max, which means minimum building, which means minimum block. Then you will get 0 here. Then you have to subtract from the current index value. Then you will get the units of water, right? Simple. By summing up all the contributions from each position gives us the total trapped water, right? I hope you understand, right? So in this way, we can get the units of water, right? So I hope you understand, right? If you have any doubts in this class, just please come into the chat and I will definitely help you out. And if you think this video is helpful for you, then please like the video and please share this video to your friends and family members so that they can be benefited from this video. And please subscribe to my channel and please ring the bell icon. Then only get the notification whenever I upload videos in the YouTube, or otherwise you will not get the notification. Thank you friends. Jai Hind.